index and selection. So bracket indexing. So basically we want to select the 8th variable in the array. We'll just put 8 in the square bracket and it will give us the 8th variable. If we want to get from the second variable to the 5th variable, you know, we start counting from 0 in Python to give us from the second to the 5th. So it will, you know, it will exclude the 5th one. So it will give us, it will actually add the 5th one here. So it will give us 1, that's after the 0, which is this, give us 1, 2, 3, 4, and excludes the last one. So that's basically that about that. Then 0 to 5 here, so it will stop at the 4th one. So 0, 1, 2, 3, 4. It will not get to 5. So that's what this is giving us now. So broadcasting. NumPy array differ from normal Python list because there's ability to broadcast. What do we mean by broadcasting? Setting value with index range. So for example, array 0, 5 equals 1, 0 to 5 equals 100. So we are changing every variable between 0 and 5 to 100. So when we run this, you can see between 0 and 5, it has changed them to 100. So here, reset array, we will see why I had to reset in a moment. So I'm resetting the array back to what we actually had. So you will see why I actually have to reset in a moment. So slicing. So we want to slice this out and save it into a new array. So 0, 6 is 0 to 6 is, from 0th position to the 6th position. So when we run that, it gives us 0 to 5. That's 0, 1, 2, 3, 4, 5 without including the 6. So when we slice, when we now change everything in this array now to 99. That's basically what we did in broadcasting the other time, and print it out. Everything will be 99. But if you now check the array now, the first 5 variables are 99. Why? Because we just copied. So the slice of array is actually still a member of the array. It's just bringing out that part that it's representing. It's something like you see just the trunk of, just the leg of an elephant. It can mean a lot of things to you. When you are touching the trunk, it can mean a lot of things to you. When you are touching the flaps, it can mean a lot of things to you. So basically, this slice of array is just giving us maybe the trunk, just the trunk. So you can't really interpret the whole thing. So until you see the whole thing. So the slice is still part of the array. It's just a slice of it. So whatever you do to the slice of the array will still affect the actual array. So the only way you can actually do that is actually to copy it. When you do array.copy, it means you are separating that one from the new one. So it's just like, it's not a copy of it, but it's not part of it any longer. Something like you photocopied a document. If you write on the photocopied document, it does not affect the new document. But if you put a carbon on a document and you are writing on the carbon, it affects the actual document. So this is like a carbon copy, carbon, and this is like a copy of the document. So if you do this and you check for all those things where we are doing, it should be different. So that's that on that. Then general format of array, that's array matrix. That's okay. Here we have generated a 2D array. So index of the array now. So when we call 1, it will give us the first row of the array. So that's what it will give us. Unlike in the vector array, that will just give us the first variable. You know, here we have 2 double square brackets. So it will see this as 1 and see this as 2. So the only way you can actually get into this and pick probably this 5 is to actually call the first row, then the first column of the first row. So that's 1, 0. So when we run this, it gives us 20. That's row 1. That's 0, 1. This is row 1. Then column 0. That's column 0. So that's why this one is giving us 20 here. Instead of using 2 square brackets, you can actually use just comma and we'll still get exactly the same thing. So you can call from 0th row to the second row. So it will exclude the last one. So that will be 0 and 1. Then from 1 to the end. So it will now exclude the 0th row. Remember, we start counting from 0. So that's how we got this one here. So the last row of our array, that's it. Then we can get everything in the last row too. So just basically using colon, the same thing as just using this. So that's that about that. Then there's another thing we call fancy indexing. So fancy indexing allows you to select entire row or column out of order. To show this, let's quickly build out a numpy array. So this is a numpy array of 10, 10, that is 10 rows and 10 columns. That's 0 in 10 rows, 0 in 10 columns. So then we check for the shape and save it inside this length. So we say for I in range array dot underscore length, that's the shape of the array now. We're now saying array 1 equals I. So we are basically what we are doing is we are changing the content of the first row to 0, content of the second row to 1, third row to 2, because this will automatically take the shape of the array, which is what 10. Then when it checks when it's now checking, so for I in this array, so when it's still 1, when it's still 0, it changes everything in that row to 0. Then it changes to 1, it changes it to 1, change to 2, it changes to 2, like that, until it gets to the length, which is what? 10. And 10 will be what? The ninth, where which will be giving us 9. So that's basically that. So it starts from 0 and ends in 9, which is why it has 10 rows. So, leaving that aside now, allowing any order. So here, we are calling a 2D array, but we are now calling different rows in the array now. We are calling different rows. So we are calling row 6 first, then row 4, then row 2, then row 7. So that's how we got this. That's that about fancy. And mind you, the fancy indexing takes 2 square brackets. Put that in mind. So that's that on that. Then selection. Let's briefly go out and use brackets to select based off of comparison operator. So what we are doing here is, okay, we created an array. Then we are saying, okay, in this array, give us the ones that are greater than 4. So which ones are greater than 4? It gives us 2 from 4, from the fifth one to the last one. That's 0, 1, 2, 3, 0, 1, 2, 3. So 0, 1, 2, 3, 4. Okay. We are not counting from 0. It's from 1 actually. So 1, 2, 3, 4. So 5 to 10, it's actually true that they are greater than 4. So to actually give us, okay, we save the false into a Boolean now. Then the Boolean, if you don't understand Boolean, please check that tutorial out. I don't want to start reinventing wheels here. So basically what we are doing here is now, for every that is true, print out the number. That's what we are doing here. So you see it's false here, it's false here, it's false here, it's false here. So it will not print out this, and this. But you print out all this because they are true. So if we run that, so you can see true, then we can run this too, and it gives us this, because we just put what we add here. Okay, let me use 4 first so that you understand. So if I use 4 and run this, you can see this, that they are greater than. It's the same thing as just putting this Boolean array inside this bracket. So let me go back to the 2 I used. So we have our 2 here. So that's that on that. So you can use maybe a variable or whatever there again. So let's come to numpy operations now. So numpy operations is basically just the arithmetic operations that we perform. So here we can easily just generate a new array, then array plus array. That's like the first one plus the second one. So it will add them on their indexes. So add them on their indexes like that. And to give us this response. So 0 plus 0 is 0, 1 plus 1, 2, 2 plus 2, 4, 3 plus 3, 6, 4 plus 4, 8, 5 plus 5, 10, 6 plus 6, 12, 7 plus 7, 14, like that. So we can multiply them by each other, which is still the same thing like the indexing. So 0 times 0, 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 multiplied by 9. Then we can subtract them from each other. So when you subtract something from something, it will give us 0. So like 1 minus 1 is 0, 2 minus 2 is 0, like that. So here it will give us an error actually, but it will still print us the answer. The reason why it will give us an error is we can't divide by 0. So 0 but divide by 0 will give us not a number. So that's the error it's giving us here. So not a number, then the others will be 1. So that's about that. Then here too will give us infinity. So and it will give us an error so that to show us that 1 divided by 0 is impossible to give us infinity. But aside that, every other thing we will divide by 1. Then to raise to power in array, we use double star. So array raised to power 3 gives us this. That's 0 times 0 times 0, 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3, 4 times 4 times 4, 5 times 5 times 5, 6 times 6 times 6, 7 times 7 times 7, like that, like that, like that. Universal array functions. What do I mean by universal array function? All those functions that we call that okay, but let's just call them, they are functions in array that we use. So basically, when we want to find square root of each variable of an array, we use this. That's sqrt. When you want to find the exponential, we use this. When we want to find the maximum of an array, we've actually treated that. When we want to find the sign, that's like the cosine, sine, and the likes like that. So this is how to find the sign. Then logarithm, like that. So this is where we come to end of data analysis with Python using numpy. So in the next tutorial, we'll dive straight into data analysis with Python using pandas. So till then, I remain your host, Abbas Olaya, and don't forget to subscribe to this channel. Thank you and God bless.